Good morning. Let's start our day with a nice 57 degrees coffee. And some music, of course. So let's start the music first. And now let's find out why I know that it's 57 degrees Celsius. So this is what you can see here. And you see 57 degrees Celsius is what it shows. So how can we be sure it's 57 degrees Celsius? How did we measure that? We are doing this with a temperature sensor. And let me show you where I put it. The temperature sensor sits here. And the temperature sensor I'm using is a PT1000 temperature sensor. And when you Google for PT1000, you will have different sensor types that you can see, like a 2-wire, a 4-wire, a 3-wire. And what is this all about? So we just put together a nice website on our Revolution Pi website, which is Basic Knowledge RTD Measurement. And here you can find out the all that you have to know about these types of sensors, and they are often referred to as RTD, where RT stands for resistance, temperature detector, and the resistance. The working principle is as follows. You take a piece of wire, and in the middle there is a metal element that will change its resistance based on the temperature. So as you can see, the length of a wire also changes the resistance. When we just take a 2-wire sensor, then we should really not cut it and keep the length of the cable as it is, because every change would affect the precision of the sensor. How to cope with that? So if we take like more wires on one side, we could measure the resistance of the cable length and subtract that from the whole value, and we get the pure value of the measuring element. And then we get a more precise value. So the more cables, the more precise is the value. We would go for a 4-wire sensor when we want to be very precise, but my taste was just fine with a 2-wire sensor. And as you can see here, like here you get shielded cables for rough environment. You get just sensors that you can dip into liquids. Some of them are resistant to aggressive fluids. And then you can see the temperature range for each sensor is different. So just have a look. There's also PT100. I think this is a PT1000 anyway, but PT100 is less precise. So go for PT1000, take a 2-wire when it's enough when you're okay with the standard cable length, and go for a 4-wire if you have to cut it. And then let's see how to get it working. What you need on the RevPi side, when you have a RevPi Core or Connect, you need an analog input module. And we offer this RevPi AIO module. And if you Google for that, you will find that it's one of our most expensive modules. This is because the precision of our analog digital converter is really incredible. So this is a high precision instrument, and you can get really precise measurements out of analog sensors like 5 to 10 volts, 4 to 20 milliamps, and RTD measurements. So once we have this, we just connect it to our Revolution Pi with the bridge on top. Then we put all in the switch cabinet and wire that up. And now we need to connect the sensor. And for this, we will be going to this point, how to configure RTD channels. And here you can see that we have 2 RTD channels. We can connect 2 sensors on the AIO. And I'm going for RTD 1. It's 16, 14, 12, 10, starting from the bottom right, so you can count up. And what you will recognize is the colors here. And when we go back to the sensor side, you can even see 2 red, 2 white, 1 red, 2 white, 1 white, 1 red. So when we go here to the configuration, this just matches this scheme. And as I'm going with the 2-wire sensor, I have to add a little jumper cable between the inputs 10 and 12, so that it just looks like a 3-wire sensor to the RevPi. Having done that, now we have our connection, everything is wired up fine. We have to configure it. So we just go to the configuration website of our RevPi and we use the username admin and the password, which is just printed on the sticker on the side of your Revolution Pi Core or Connect. So let's log in. And now we will be going to Pictory. And in Pictory, we will set up a configuration for this. So first of all, we pick our model of the RevPi, Core or Connect. So in my case, it's a Core. Then we just add the AIO module. Please do it on the left-hand side. So here's my AIO. And now we have to add some configuration. This is because you can see the temperature sensor range here starts from -30 to 180 degree. So we have to find an offset which starts at -30 and scales the range of the sensor to the range of -30 to 180 degrees. And how this is done, you can see here. We have down here the description how to do it. And for me, it's just, the standard setting. If I go down here on the AIO, of course, let's scroll down. RTD1 type is PT1000. RTD1 wiring, 2-wire, multiplier 1, divisor 10, offset 0, and that's our settings. So my settings, yours might be different. And then I get a value. And this value goes to RTD value 1, and as RTD value 1 tells me nothing about what it is, I just renamed it into coffee temp. And now I can go to File, Save as Start Config, Tools, Reset Driver, and then I'm good to go. So let's look at Node-RED, how to use it in Node-RED. Of course, this value can be now used from any solution you are using with Revolution Pi, CodeZeus, Python with RevPi-mod.io or whatever you want to use. But in my case, it's just a simple Node-RED interface. To start that, I would go into the configuration menu once again. Then I will just go to the Services tab and start the Node-RED. So I enable the Node-RED service and I enable the Node-RED RevPi node server. Then I restart the system. And then I can just call my system with coffee 1880 and I will land on this. And here on the left hand side, we will have these Revolution Pi nodes. And I'm just going for a slow cycle. This is very slow, just every 5 seconds. And then I got a get pin, RevPi get pin, and I connected it to the local server, so nothing special here. And here I can choose all the values that our Revolution Pi has, of course also the coffee temp. And that's pretty much it, so I can use it. How did I do this on my display? Let me show you. This is not needed, this is needed for different stuff, so these 3 things, you can just ignore them. You can use a donut element, for instance. And this will result in this donut element. So 57 degrees Celsius coffee. Let's find out how I did that. I just took the donut element, put in the value format with the degrees Celsius, and I abused the units for my coffee label. Then I put in a range, and I hope my coffee doesn't exceed 70 degrees Celsius. And I got a color gradient which matches my taste of color. And then I end up with this donut diagram. And if I want to add a line chart, then I can do it. This is just done by choosing where is it? Let me see, the chart node and connecting it with the temperature sensor. And then I just use as a label temp. I have 2 hours then I go for a value between 0 and 100 degrees Celsius, and that's pretty much it. So not a lot to configure, and then I end up with this chart. So now I know when I pour coffee, it will have 57 degrees Celsius. I wish you a good day. Thanks for watching.